Nuclear physics began in 1896. Anthony Henry Becquerel was born on 15 December 1852 until 25 August 1908, was a French engineer, physicist, Nobel laureate, and the first person to discover radioactivity. For work in this field, he, along with Marie Sklodowska-Curie and Pierre Curie, received the 1903 Nobel Prize in Physics. The SI unit for radioactivity, which is the becquerel, is named after him. Henry Becquerel discovered that a mineral containing uranium could discolor a photographic plate even if it was wet to block light. It was evident that the mineral released a novel type of radiation that, unlike X-rays, which is section 2511, did not require an external trigger. This new phenomena became known as radioactivity. Basically, radioactivity is the emission of ionizing radiation or particles caused by the spontaneous disintegration of atomic nuclei.
There's a physicist named Marie Curie who discovered two elements, which is polonium and radium. Later, in 1898, she won the Nobel Prize for Physics for discovering radioactivity. After Becquerel's discovery, Marie Curie and her husband, Pierre Curie, isolated two elements, which is polonium and radium, which previously they are known as very highly radioactive. In many cases found, radioactivity was discovered unaffected by any strong physical or chemical treatment, including strong heating, cooling, or the action of strong chemical. It was suspected that the sources of radioactivity must be deep within the atom, coming from the nucleus. It clearly showed that radioactivity is the result of decay of an unstable nucleus and emits some type of radiation or rays.
There are two types of radioisotopes, which are natural radioactivity and artificial radioactivity. Firstly, there are many unstable isotopes occur in nature, and such radioactivity called natural radioactivity. Some elements, such as uranium, does not have stable isotope. Natural radioactivity provides stressors in a wide range of characteristics, timescales, and radioactivities, which can be used as tools to study the rate of reaction and transport processes in the ocean. Next, the unstable isotopes can be produced in the laboratory by nuclear reactions. These are said to be produced artificially and to have artificial radioactivity. It is a process of using radiation to make a previously stable material radioactive. The example of natural radioactivity are uranium-238, berkelium-243, and carbon-14. Medical imaging technology, nuclear reactor, and particle accelerator are the examples of artificial radioactivity.
Let's move to the Rutherford's discovery. Ernest Rutherford, a New Zealand physicist, and others, which are his co-workers, began studying the nature of the rays emitted in radioactivity about 1898. Rutherford studied the radiation emitted by uranium, and he discovered two different types of radiation. One type of radiation could barely penetrate a piece of paper, while the second type only could pass through as much as 3 mm of aluminum. While studying radiation emitted by radium, Paul Villard, a French chemist and physicist, discovered the third type of radiation in 1900, and the third was extremely penetrating, that it could pass through several centimeters of lead and still be detected on the other side of the lead. They classified rays into three distinct types according to their penetrating power. They named these three types of radiation as alpha, beta, and gamma respectively, after the first three letters of the Greek alphabet.
So when we talk about the magnetic field characteristic of rays, we're delving into the interaction between electromagnetic wave, which is like light, and the magnetic fields. So basically, when a light passes through the magnetic field, it experiences a force due to the magnetic field's influence. So this force may causes the path of ray to deflect or to bend. And the degree of deflection depends wholly on the factors of like the strength of the magnetic field and the properties of the material which the ray is passing through. So in like some more complex cases or scenarios, like when the light encounters the magnetic field, which is created by the electric current, the interaction becomes more intricate. The magnetic field will be induced by the current, which interacts with the moving charged particles in the light, and it affects the overall behavior of the ray. So I believe that understanding this magnetic field characteristic of ray is crucial in various scientific fields, from optics to astrophysics, as it provides insight on how electromagnetic wave responds to the presence of magnetic fields in different environments.